Hello students, this video is all about graphs of functions. Here we will learn how to represent graph as a set. We defined actually in the previous video like how we defined graph as a set, and we learned how to sketch it using table of values, take arbitrary x values and correspondingly calculate the functional values and plot them on the coordinate plane. So that is what we learned, and here we will learn about some special graphs like linear graphs or linear functions, power functions and root functions, etc. So if we are given a function f from a to b, so that means a is the domain here. So how do you plot this function? If you are asked to plot the function, how do you plot it? You take a point x from a and calculate the functional value at x, that is apply the rule f on x and plot this as an ordered pair like this. So where x will be the x coordinate and f of x will be the y coordinate. So we can define graph of a function as graph of a function f with domain a as set of all ordered pairs x comma f of x such that x belongs to a. So if we are asked to write the equation of the graph, that would be y is equal to f of x. So this is nothing but the equation of f. So that means you can solve any equation using a graph or using the pictorial representation of a graph. You will learn all that in the future videos. So now to define linear functions. Linear functions. These are the functions of the form f of x is equal to mx plus b, where m is nothing but slope of the function and b is the y-intercept. You know what is an intercept and you know what is a y-intercept. That is a point where it touches the y-axis. So f of x is equal to mx plus b. This is a linear function. Why is it called linear? Because if you plot it, it would be similar to a straight line. It looks like a straight line if you plot the values on the coordinate plane. So a special case of this linear function would be when m is equal to 0. So that would be f of x is just b, because b is a constant. This particular function is nothing but constant function. In this case, if b is also 0, that would be the function would give us just the x-axis of the coordinate plane, and if b takes any value other than 0, so it would be horizontal or parallel to the x-axis. So for any input values, you just get one output value, and that is constant. That would be a real number if you are, because we are in the real plane. So that's why it is called as a constant function. So now we will learn how to plot two more special kinds of functions that are called as power functions and root functions. Power functions are of the form where you have the output to be expressed as a power. F of x is nothing but x to the power of m, where m can be any real number. So we shall plot one such function. So if I consider if I consider f of x to be equal to x square minus 4. Okay, so now it is the same way that we plotted, we learned plotting or sketching the graph in the previous videos. We will take arbitrary values of x and calculate the functional values. So here, why is it a power function? Because one of its term is a power of x. Okay, so so x is x and y is equal to f of x. So if I consider 0, 1, 2, 3, -1, -2, -3 to be the arbitrary values of x, so the corresponding y value, that is f of x values for the given values of x, is when x is 0, y will be -4. When x is 1, y will be, that is f of x will be 1 minus -4, because 1 square is 1. 1 minus -4, that would give us -3. And when x is 2, we will get 2 square is 4. 4 minus 4 is 0. When x is 3, we get 9. 3 square is 9. 9 minus 4 is 5. So the same value repeats for the negative x values as well, because squaring a negative number will give you a positive number. So we will repeat the values. It would be -3, 0 and 5 again. So now to plot this on the graph, so we will get 0, -4. This would be 0, -4. So that would be here. Okay, 1, -3. 1, -3 is here, and 2, 0. So 2, 0 will be on the x-axis. 3, 5. 3, 5 is here. Okay, then -1, -3. -1, -3 is here, and -2, 0 is on the x-axis again, and -3, 5 is here. So this is a parabola. Connect all the points. So this would be the graph of the equation. F of x is equal to x square minus 4. Okay, now we will draw or sketch the graph of a root function. Root function is defined to be of the form f of x is equal to x to the power of 1 by n. That is the power function with a special case where the power of the x coordinate or power of the function would be an exponential power. So that is what will give you roots, right? So this is how we define root functions. So we shall try plotting or sketching a function, a graph of a function which is a root function. So a very simple function, that is f of x is equal to square root of x. So I will consider arbitrary x values again as I did in the previous case and calculate the corresponding functional values. That would give us y is equal to f of x, that is equal to square root of x. So the values that I consider 0, 1, 2. Okay, this will make our task difficult. So I will consider, because square root of 2, to identify it is difficult. So I will consider some perfect squares and mostly positive ones, because we haven't defined square root of a negative real number. So that would be 4, then 9, then what else, 16, then 25. Okay, so these are perfect squares. I'm just trying to make our task easy. You can do like consider 2, 3 and all, and calculate it using a calculator. Okay, and plot it on the graph. Okay, so for square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, and square root of 9 is 3, square root of 16 is 4, square root of 25 is 5. So if we have to plot this, so plot this, 0 comma 0 is here, 1 comma 1 is here, 4 comma 2 is here, okay, 9 comma 3 is, okay, I don't have 9 and 16, I have to extend the line. Okay, I'll do that. I will not be able to plot 25, so this is 8, 9, 10, 11, 12, 13, 14, 15, 16 is somewhere here. Okay, I can plot only up to 9. I don't want even to try 16. So 9 comma 3 would be 9 comma 3, it's somewhere here. Okay, and yeah, I can do 16 comma 4 is here. So connect all the points. So this is how your root function looks like. Okay, so this is how we sketch the graphs, and we learned types of functions that are, we learned what are linear functions, what are constant functions, and what are power functions, and what are root functions, and we learned how to plot them in this video. In the next video, we will learn about graphing piecewise defined functions. We learned what are piecewise defined functions in the section 2.1. So we will learn how to graph it, and how to extract data out of these graphs, these sketch of graphs. Okay, see you in the next video. Yeah, before that, I should be giving you the quiz. So yeah, quiz 2.2.1 is sketch sketch the graph of the following k of x is equal to negative cube root of x. Second, you can use a calculator to find out the values. Sketch the graph of the following. You should use table of values. Using table of values, and the second function would be g of x is equal to x minus 1 the whole cube. I think there was such a question in your exam. Yeah, okay, do this as a quiz. Meet you in the next video. Thank you.